Potential energy tends to be one of the most poorly understood concepts in chemistry, but is also one of the most important. So let's start off with a definition. Potential energy is a form of energy related to the position of charged particles in a system. Let's start off by considering what we mean by a low potential energy system. All this really means is that we have a favourable arrangement of charged particles. And this means that my system would be considered stable. A high potential energy system, on the other hand, is a system in which we have an unfavourable arrangement of charged particles. And therefore this system would be considered unstable. So whenever you hear the words stable or unstable throughout the course, you really need to be thinking in terms of potential energy. Let's have a look at a few examples. Here are three systems, and each system contains a positive and a negatively charged particle. And with our understanding of electrostatic forces, we should know that oppositely charged particles will be attracting one another. If the two particles are attracting each other, then the most favourable arrangement of them would be when they are as close together as possible. So in this example, system C would be the most favourable arrangement. Therefore, it is the lowest potential energy system of the three, and would be considered stable, or the most stable of those three systems. On the other hand, the least favourable arrangement would be when these oppositely charged particles are furthest apart. This would be the highest potential energy system of the three, and therefore considered the least stable. Let's try a second example. In these three systems, we have two particles again, but this time both particles have a negative charge. And with a basic understanding of electrostatic forces, we should know that things of a like charge will repel each other. If the particles are repelling each other, the most favourable arrangement would be when they are furthest apart. In this case, that would be system A. Therefore, this system would be the lowest potential energy of the three, and considered the most stable. So, which system then would be the least favourable arrangement? Well, if the particles are repelling each other, the least favourable position they could be in is right next to each other, in this case system C. So system C would have the highest potential energy and would be considered the least stable. Let's have a look at one final example. This time, each system contains two positively charged particles and two negatively charged particles, so we need to identify which would be the most favourable arrangement. Because there are more than two particles in this case, we need to consider all of the attractive and repulsive forces at play. In system A, my positively charged particles are next to negatively charged particles, but they are also right next to particles with the same charge. In system C, the two particles in the middle with opposite charges are next to each other, which is good, but the particles with the same charge are also right next to each other, which is not good. System B seems to be the most favourable arrangement because each of my particles is next to two particles with opposite charges. And although the particles with the same charge are kind of close to each other, they don't appear to be touching in this diagram. If this is the most favourable arrangement, then we consider it the lowest potential energy state of those three, and therefore system B would be considered the most stable. Let's briefly summarise the key points from this video. Firstly, potential energy is a form of energy related to the position of charged particles in a system. A system with low potential energy is one that has a favourable arrangement of charged particles. And this kind of system we would describe as being stable. A system with high potential energy contains particles in an unfavourable arrangement and is considered unstable. The particles would likely move position to reach a lower potential energy state. And that's it for potential energy. It's a really important one in chemistry, so hopefully this video is of some help.